3 weeks and 1 click on this button got us this pizza. Let's go. Today we're going to talk about smart buttons. The CEO came in a few days ago and said that he has a vision. The world needs more buttons. So we figured, okay, we'll build these buttons, but what will the buttons do? What will the button do?
Order pizza?
Order pizza, exactly. Why will it order pizza? Because we're a high-tech company and we eat healthy and we don't get any pizza because we're all into lettuce and health. So we're gonna make a button this episode that you click and we'll order pizza. And we're gonna build it from scratch. Designing it, 3D print it, laser cut parts of it, do the electronics, figure out the battery consumption, LEDs, do the coding of the firmware on the controller, have the server, do some kind of a back-end work to actually order pizza. What are you doing? We're filming.
Writing comment on this video. Amazon did that already. Try something new.
Right. Amazon had Amazon's Dash button, that's true. Project that they had a few years ago, and it was part of the inspiration for this project. We're gonna do something much cooler with way less budget, way less time, and it's gonna be awesome. All right, so let's get started. Looking, push the button.
You know it's not real.
And now all I have to do to get that pizza is press that button and the pizza will come now. Here we go. So let's build out this smart button. So we're gonna need the microcontroller. We'll be connected to a button. Once you click it, it will send a request to a server and the server will order the pizza. We need LEDs to indicate to the user if the button is clicked. We need some kind of a charging circuit, which will be connected to the microcontroller and to a battery. We will need a button, some kind of a tactile switch. Once the button is clicked, that will toggle the LEDs to do some kind of effect. The device will then connect through Wi-Fi. It'll send a request to the server on the cloud. So we need to find a way also to provision the microcontroller. So now that we have some kind of a overview strategy, let's choose the parts we'll need for this project. So in terms of selecting the microcontroller, we have here the Arduino Mega, Arduino Uno, Arduino Nano, and Pro Mini. We have the ESP32 and the ESP8266. These two guys, they have Wi-Fi capabilities, so we're gonna take one of them. The ESP32 also has Bluetooth capabilities and it has a lot of memory, so I'm gonna go with that one. It's my favorite for these kind of projects. In terms of LEDs, I like to use the WS2812B. These are addressable LEDs. You can control each LED separately, RGB, and their brightness. For a button, we'll just use one of these tactile switches. In terms of batteries, we're gonna go with LiPo batteries. Why? Because their voltage works well with the ESP32. They run from 3.7 to 4.2 volts when they're fully charged. We have a few options and it's really a form factor that I want to take into consideration. I want the button to be as small as possible. So we're probably going to go with these guys. They have 800 milliamp hour. One of the reasons we're going with LiPo is so that we can charge them. They can be recharged. In order to recharge them, we're going to use a charging circuit. These are really inexpensive. It has overcharge protection and a whole bunch of different protections that you want to use. So I made a first design with an enclosure, which we're gonna 3D print. And then we're gonna cut the top part of the button on the laser machine. We're gonna cut it out of 3mm acrylic frost material so the LED can show through. And we're also gonna print out a little adapter that will sit on the tactile switch and we'll glue that to a little piece of acrylic to create the button. So I put together here a prototype with the ESP, with the button. We have the charging circuit, we have the LEDs. I wired them all up and I wrote a basic sketch, uploaded onto the ESP32, a sketch where once the button is pressed, flash the LEDs and connect to the server and send some kind of request. Right now I have the Wi-Fi credentials hard-coded onto the code, but there are a few ways to get those credentials onto the board without actually hard-coding them. So I collaborated with a friend who designed a bunch of PCBs in the past, and together we designed this awesome PCB for the button. So we have the schematics over here, which show the logic of which components wired to which component. And then we have the actual board itself, where we can see where every component sits physically on the board and how all the routing of the wires happens. We added a circuit for the charging. We added an option to know when the battery is being charged and how much voltage it has left. So let's zip up all these files, send them to China, and see what we get. It's here. Quicker than I expected. It took about 2 weeks and it arrived. Here we're going to connect the LED. We have their power, their data, and their ground. And here we're going to connect the batteries from the bottom. I have the plus and minus for the battery. All right, we have our PCB assembled. We have our LEDs soldered to it and a battery connected in the bottom. Let's throw this into the case that we printed. Assemble the laser cut top. So now we'll go ahead and finalize the code and upload it onto the controller. Since we don't have a USB port on this thing, we're going to use an FTDI programmer in order to upload the sketch onto the board. So when you click the button, it turns green until it gets an answer from the server, and then the green comes off. So I also added a feature that when you charge it, it'll give you a nice cute little charging effect, and the faded color will indicate the level of the battery. Pretty cool, huh? So we have this nice looking button over here. It works in terms of hardware. We now have to make it actually order some pizza. So let's go to Ido over there and ask him to make some kind of API or some kind of way for this to order some pizza. So I made this button over here. When you click it, it connects to the local Wi-Fi, and then it sends a request to a server. I'd like this to order pizza.
All right.
Can you make that happen somehow?
Let's check. I'm not sure. I think there's an API or some kind of WhatsApp or Messenger integration for pizza. They have this website where you can place your orders online, and maybe we can look into the network traffic and see if we can mimic their request to submit our own orders from our custom APIs.
Cool, sounds good. So I want to dive into it and let me know if it's possible.
All right.
So what do we got?
I looked into it and I saw that the system that Pizza uses it's a company that specializes in online ordering via WhatsApp bots or Messenger bots. On their website, there's a demo store for Pizza. So I tried looking into the website and kind of copying whatever I could see on the network tab, and that did not seem to work. But I used a software called Fiddler, where I could filter the web requests and actually edit them one by one and see what exactly did not work. And then I created a Firebase function in Node.js where I do the same request. And we can test it out on Postman and see that when we send this request, we have to wait a few seconds, and then we're going to see a confirmation number. And that confirmation number, we'll get it also by WhatsApp and by mail.
All right, so let's do it. Send me the endpoint and let's make it to production and let's order some pizza.
No problem.
Cool. All right, and now all I have to do to get that pizza is press that button and the pizza will come now. So here we go. Okay, it'll take like 40 minutes. All right, the pizza's arrived. Hi. Voila. It worked. Great success. So we hope you enjoyed the video. Making this button was a lot of fun. If you want to see similar content or anything different, let us know in the comment section below. Don't forget to subscribe and like this video, and we'll see you on the next video.
I'm ready for something sweet now.
Me too. Let's make an ice cream button.